In this tutorial, we'll take a look at the number sense topics for the EQAO math proficiency test. So that's operations, adding, subtracting, multiplying, dividing, numbers, square roots, involving whole numbers, integers, decimals, fractions, expressing whole numbers using place value and an expanded form, some working exponents, and evaluating numeric expressions involving order of operations for BEDMAS. And we'll see some of that right down here. So in A, we have, and I didn't put any multiple choice in this tutorial, just wanted to talk about lots of different examples about number sense. So 6 plus negative 4, subtract negative 3. Now, when you're adding a negative, that's the same as just subtracting. So 6 plus negative 4 is the same as just 6 subtract 4. And subtracting a negative is the same as adding the opposite. So actually any subtracting is the same as adding the opposite. So we change the subtracting into adding, and it's the opposite integer to negative 3, which would be a positive 3. So that's how you kind of make this simpler. So 6 take away 4 would be 2, and then we're still up to plus 3 here, and of course 2 plus 3 adds to 5. If you happen to have your calculator with you, you could just go 6, let's see if we can do this with the calculator, plus the 4, and we'll make it negative, equals, and then I'll do the subtract negative, so subtract 3 and make it negative, and we get 5. Okay, but you have to make sure you type it in the calculator correctly. So again, clear 6 plus the 4 and make it negative, and then subtract the 3 and make it negative, gives you 5. So it is possible to do that with the calculator, but you have to type it in the calculator in a very specific manner to get that 5. Number B here. Now this is a BEDMAS question because we have multiplying, and adding in between. So now there's no brackets, no exponents. So after you've done those, or if there aren't any, then you go to the division and multiplication. You just do an order from left to right. So we've got two multiplications. So we're going to do the 2 of those, and then after we evaluate those, we'll add. So 2 times 3 is 6. 3 times 4 is 12. So we're adding 6 and 12. Of course, that adds to 18. For C here, now when you see a number written right beside a bracket, that's implied multiplication. You don't normally put a multiplication symbol there, but there is multiplication there. Now, brackets, inside the brackets, we're adding 6 and negative 4. So I would evaluate that first. And since that's separated with an addition sign, we can actually do this at the same time. So 6 plus negative 4, again, is same as 6 subtract 4. Negative 3 times 2 is negative 6. Now, 6 minus 4, of course, is 2. So this is negative 5 times 2. And adding negative 6 is the same as subtracting 6. So negative 5 times 2 would be negative 10. Subtract 6 would be negative 16. Just to model this with, I often use a thermometer. Like if you were at minus 10 degrees, subtracting 6 means it's going down 6. That would be at minus 16 because that's 6 degrees colder than minus 10. Just to give you an example. On the second page, some exponents and fractions. So first of all, exponents, when you're dividing, you to write this as a single power. So right now we have 2 powers divided. In order to write it as a single power, we subtract the exponents. And I'll give you some examples on the next page of why we do that, just to show you why you subtract them. I didn't make one up here. So 13 minus 8 is 5. So this is 2 to the 5th, which actually means 2 times 2 times 2 times 2. There's 5 of them multiplied. So 2 times 2 is 4, times 2 is 8, times 2 is 16, and 16 times 2 is 32. And of course, you know, if you had the calculator, there is no exponent key here. You just have to go clear 2 times, that's the second one, third one, fourth one, fifth one, and there's the 32. You just have to make sure you count how many you're typing into your calculator if you have it to use. Remember on the The first, I think it's 6 or 7 questions of the math proficiency test is non-calculator. So there could be a question like this where you actually have to do it without a calculator aid. E, dividing fractions. When you're dividing fractions, that's the same as, and we change this into multiplying by the reciprocal. So dividing by 3/4 is the same as multiplying by 4/3. Now, what we do is, I'm going to write the 30 as a fraction. Right now, you don't see a numerator, or sorry, denominator. 30 is a numerator. There's no denominator, so that's automatically 1. So 30 over 1 is 30, and we're multiplying by 4/3. So 30 times 4 in the numerator will be 120. 1 times 3 would be 3 in the denominator. And 120 divided by 3, 3 goes into 120 40 times. Now, just to show a shortcut, and maybe you've seen this at some point. See, you can actually, at this place here, you can notice that 3 goes into both 3 and 30. So you can divide 3 goes into that once, and 3 goes into 30 10 times. So it's now 10 times 4, which is 40, over 1 times 1. So like this is really 40 over 1, which is just 40. So you don't have to go directly through this. If you see that dividing out that you can do. Now, F here, we're multiplying these two fractions, and when they're in mixed form like this, change them to improper. It's very difficult to actually multiply these. It's because you kind of have to do the 5 times 2 and the 5 times 5/7, and then the quarter times 2 and the quarter times. It's very complicated to do in mixed form. So to make it easier, we change them to improper form. So to change 5 1/4 to improper form, I go 5 times 4 is 20, plus the 1 is 21, so that's 21 quarters. And 2 times 7 is 14, and then 14 plus 5 gives you the 19 sevenths. Now, something we can, that dividing out, some people call it canceling. You see 7 and 21, 7 actually divides into 21. So 7 goes into itself once, and 7 goes into 21 3 times. So now what we have is we have 3 times 19 in the numerator, and that's 57. But if you didn't know that, just 3 times 19 is 57. So here's our, and I didn't do the dividing out. I wanted to show you how that works in this one. So here's the 3/4 times 19 over 1. And so 3 times 19 is 57 quarters. Now, if you were asked to change this back into mixed form, this is what we would do. How many times does 4 go into 57? Well, the 57 divided by 4, okay, is 14. Okay, so this is going to be 14. Now, to figure out how many quarters are left, 14 times 4, see, that's 56. Let me bring the calculator back here. See, 14 times 4 is 56. And see, there must be one more to make the 57. Also, if you remember any of your fractions at all, see the 0.25 is the quarter. Okay, so that's 14 1/4. 14.25 is 14 1/4. Now G here, we're asked to add these 4 decimals. And notice they have different numbers of digits to the right of the decimal. There's 2 digits, 3, 4, and this one actually is 5. So, how do we rate them? Do we right justify them? No, you don't do that. But that's what this is, right justified. Very challenging to add them if you write them like that, so we don't do that. Well, what if we left justify them? Look like this. So see, the problem is you're supposed to have the decimals lined up. So the correct way to do it would be like this. And actually, it doesn't matter what order you write them. Okay, that will not change your answer. So we're adding. So now there's nothing to add to the 4, so we just put a 4 here. 0 and 2 is 2. 9 and 5 is 14, so we put a 4 here, and we carry the 1 up here. So that 1's going to get added to this 1 and this 3. So 3 and 1 is 5, so we put a 5 here. 8 and 2 adds to 10, so we put a 0 here and carry the 1. And notice I have my decimals right here, so my decimals here. 1 and 7 add to 8, and of course there's nothing to add this 1 to, so we just put 1 here. So it's 18.05424. G, one last question on this page here. So we're adding and subtracting some fractions and whole numbers, subtracting 2 here as well. So the 3/4 and the 2/5. In order to add them, see, quarters and fifths aren't the same size. We can't add those right now because it's kind of like we're adding different sizes of things when the denominators aren't the same. So we need to find the least common denominator. So if you write out the first several multiples of 4, they're 4, 8, 12, 16, 20, 24, etc. The multiples of 5, the first several are 5, 10, 15, 20, 25, 30. The least common multiple of them, or the least common denominator, is the first number that appears in both lists. See, 20 is a multiple of 4, it's also a multiple of 5. So that's what we're going to use for our common denominator. So I want to change both these denominators to 20. So you ask yourself, what do I multiply 4 by to make 20? And it's 5. And what do I multiply 5 by to make 20? And that's 4, of course. We multiply by 4. And you do the same thing to top and bottom. Otherwise, they're not equivalent fractions. So 3 times 5 is 15 twentieths, and 2 times 4 is 8 twentieths. Now, we can add the 15 twentieths and 8 twentieths together to get 23 twentieths. And we're subtracting 2. Now, I changed the 2 into 2 over 1 because I'm going to, again, get a common denominator so I can subtract these. I could have done that right from the beginning, I suppose, too. But I wanted to kind of do 2 things at a time here, not too much. So the common denominator between 1 and 20 is 20. So I would multiply this one by 20 top and bottom. So it's 23 twentieths, and then this is going to be 40 twentieths. So it's 23 twentieths, subtract 40 twentieths. 23 minus 14 is negative 17 twentieths. And again, if you had the calculator with you, and see, notice I always hit clear, because otherwise something that you just did, it might interfere with the calculation you're going to do next. So always clear to start at 0. 23 minus 40. Okay, there's the negative 17 twentieths. On to the third page. So example number 2, we're asked to write the 20,475 in expanded form. So these are what expanded form looks like here. So this means, so the 2 means 20,000. Now there's no thousands number here, it's just 0. So this would be 400 and then 75. So this is kind of on the way to expanded form. So expanded form is you always write it as a single digit times some power of 10. So 20,000 is 2 times 10,000. So that's 20,000. 400 is 4 times 100. 70 is 7 times 10. And 5 is 5 times 1. 1 is actually technically still a power of 10 because you can think of the 1 is actually 10 raised to the exponent 0. So technically 1 is a power of 10. So that's how you write this in expanded form. So it's 2 times 10,000 plus 400 is 4 times 100 plus 70 is 7 times 10 and then plus the 5 times 1 in the end. And now in example 3, we're asked to do the opposite. We're given the number in expanded form. And so look through the powers of 10. Notice it goes 1, 10, 100, 1,000, 10,000, 100,000, million. There's no powers of 10 missing. They're all in order. Notice, okay, there's 1 0, 2 0, 3 zeros, 4 zeros, 5 zeros, 6 zeros. So that means you can actually just write its number 5, 7, 1, 3, 6, 2, 9. So 5, 7, 1, 3, 6, 2, 9, which is 5,713,629. So see, here's the 5 millions, here's the 700,000, here's the 10, and 3 is 13,000, etc. Now in B here, this example I made up, there are some powers of 10 missing. See, this is 10 million. Notice there's no million. It goes right to 100,000s. And then there's 10,000, that's fine. Okay, that's the next power of 10 down. But notice there's no thousands here because it jumps from 10,000 to 100. Okay, and there's no tens, it goes right down to 1. So when you write this one out, so 8 times 10 million would be 80 million. So we put 80. And you see, remember, there's no millions. That's why there's a 0 here. Now, 700,000, so I would go 7. And see, there is, 100,000 to 10,000. There's nothing missing in the middle here. So we would put a 5 right after the 7. But there's no thousands here between 10,000 and 100. So that means we would have a 0. And 4 times 100 is 400. There's no tens, so that's why there's a 0 next. And then we have a 9 on the very end. And I just want to point out that it might be, if you answer this really quickly, especially if you did that one first, you might say, oh, this must be 8, 7, 5, 4, 9. But see, there's a whole bunch of powers of 10 missing. Those are placeholders. So there has to be a 0 here, and a 0 here, and a 0 here. And of course, 80 million is a lot different than like 87,000. Okay, so this is not how you would write that one in expanded form. Or sorry, the number, the standard form number. So so a little more exponent work here, or with powers, and I'm going to show you why we add when you're multiplying and subtracting or dividing. So 7 to the 4th times 7 to the 5th, we add the exponents. So 4 plus 5 adds to 9, so this would be 7. So that's how you write that product, is a single power. Now, why do you add? Well, 7 to the 4th means there's 4 sevens multiplied, and 7 to the 5th means there's 5 sevens multiplied. So you see, altogether there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 sevens. A common mistake here is some people will sometimes think, okay, this base is 7 and this base is 7. We multiply them, so it's 49 to the 9th. But it's not. They're not 49s multiplied here. There's a whole bunch of 7s multiplied here, so the base stays the same. In B, dividing, so 6 to the 20th divided by 6 to the 12th, so you subtract the exponents. So to write this as one single power, it would be 6 to the 8th. And of course, you could evaluate that if you want it. My point here is how you write it as an equivalent single power. Now, 6 to the 20th means there's 26's multiplied. And we're dividing it by 6 to the 12th means there's 12 sixes multiplied. Now, all of this divides out. You see, that's the same thing on top and bottom multiplied. And what you're left with here is 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sixes multiplied. That's what 6 to the 8th exponent means. Okay, last page, we're going to do a division here and then talk a little bit about place value before we end the tutorial in number sense. So complete the division and state the remainder. So we're dividing 23 into 4,735. So first of all, you look at 23. Does it divide evenly into 4? Well, 4 is a single-digit number, so certainly a two-digit number doesn't go into it. So then you look to the next number, okay, 47. Does 23 go into 47 one or more times? And it does. And of course, you can get your calculator to aid you with this a bit. 47 divided by 23, okay, it's a little over 2, okay? So we would put a 2 right here. Now notice it's above the 7 because we went to, it's 47 we were dividing by 23. And 2 times 23 is 46, and we subtract. So 47 minus 6 is 1, so put a 1 here. And then we bring the 3 down. Now 2 and 23 into 13. Well, see, 13 is smaller than 23. So 23 doesn't go into it even once. So that means we put a 0 here, and we bring the 5 down. Well, how many times does 23 go into 135? And of course, if this is the number sense part that you didn't do the calculator with, you wouldn't have this aid. You'd have to do a long division to figure out how many times 23 goes into 135. But 135 divided by 23 is, well, it's 5.86, so it goes in 5 times with some remainder. So we put a 5 up here, and we multiply 5 by 23. See, 5 times 20 is 100, and then 3 times 5 is 15 more. And again, we go back to the calculator if we wanted. 23 times 5 is 115. So we'll bring this over here. So we put 115 here, and we subtract. 135 minus 115 is 20. That's the remainder. So the division looks like this. We divided 4735 by 23, and our answer is 205 with a remainder of 20. That's how you write remainder 20, R20. So that's an example of long division. And place value, I'm sure this will come up at some point, or it may come up some point in the proficiency test. So remember, it goes ones, tens, hundreds, and then it goes thousands, tens of thousands, hundreds of thousands, millions, tens of millions. This next would be hundreds of millions. If you want to put it on the edge so you can read it more, that's what it looks like. After tens of millions, it'd be hundreds of millions. Okay, and then it'll go to billions. I'm sure it's not going to go too far, but that's the first several places, what they look like. So that's the end of the tutorial. I suggest you try the practice exercises. Look in the description for the video, and there'll be links to some practice exercises and then another answer document that goes with that. And good luck in the proficiency test.